The only reason why, frankly, you should learn Scala is because, two major libraries of two major frameworks from Apache, like Apache Spark and Apache Kafka, their major implementations, they have written their implementations in Scala. And that's one of the major reasons why Scala became so popular in the last couple of years. And also there have been various other frameworks like Akka framework, like Play framework, and a lot of other, a lot of other database tools, database management, relational mapping tools, which were released by Scala. So that's one of the reasons why Scala became very popular in the last 2-3 years, because of major frameworks which have released in this particular area. It's not only big data, even a couple of other frameworks like Akka or Play, and even there's something called FRM, functional relational mapping tools, which have been released. And that's what makes Scala a little bit more popular. Okay, Rao is asking me that what about Python with Spark? How are real-time projects distributed for Scala and Python between Spark? So Rao is asking me that, what about PySpark? The Python APIs for Spark, and how are projects distributed between Scala and Python with Spark? Now, there's one interesting thing. I got a survey results from Databricks. Databricks is the company which was formed by the founders of Spark. So these people who founded Spark, they founded a company called Databricks, and they did a survey this year, 2016 survey, and it's very surprising that for the last 1 year there has been a huge shift, from Scala to Python. So a lot of people are actually moving to Python when it comes to Spark. So, and I'll tell you the reasons later, why people are moving to Python gradually. And maybe you should also have that plan, to learn Python as well. But Scala is important. You should know Scala. You should know the Scala APIs. But having said that, I think the next one which should be on your radar to do the learning is basically you should have Python. Okay? But I'll tell you the reason later why Python is required, why people are gradually moving to Python. So here is the person who is one of the co-founders of the Scala language. His name is Martin Odersky. He works in a company called, not a company, he works in a university called EPFL. It's called École Polytechnique Fédérale Lausanne. So there's a place in Switzerland called Lausanne. So in Lausanne, he works in the School of Polytechnic. So it's called École Polytechnique Fédérale. So that's where he works as a professor for computer science and mathematics. And he's the one who came up with the whole, grammar and the whole compiler design for the Scala language. So as we can see that, Scala is a general purpose programming language. And so general purpose means, you can actually use it for anything you want. You can use it to write Spark, which is a cluster computing framework. You can use it to write a Play framework, which is a web development framework. You can use it to write Akka framework, which is an actor-based concurrency framework. So it's a general purpose language, it doesn't have any fixed purpose. You can just use it the way you want. And it's a combination, as I told you before, it's a combination of object-oriented programming and functional programming styles. So now you know what this means, So now that I've explained to you, so you know what these two phrases mean. And this was publicly released in 2004 on a JVM platform. And later, a few months later, it had a release on the .NET platform. So they started working around early 2000, and now we have pretty stable releases of Scala, which comes out. Now here are a couple of features of Scala. The first feature is that it's statically typed language, and by statically typed language I mean that you have to declare the type of the variable. Unlike languages like Python or Ruby or JavaScript, where you don't have to declare the language, you don't have to declare the variable type. But here in Scala, you have to declare the type of the variable. Okay, so you have to tell the compiler what is the variable type, so that it can actually do something meaningful with that. And it's mixed paradigm. I told you it's mixed paradigm because it fully supports object-oriented programming concepts. It has functional programming concepts as well. And just remember that everything is an object in Scala, so you don't have a concept of primitive types. If you know Java, you will know that Java has primitive types, but in Scala there is no primitive types. Everything is an object in Scala. Okay, so unlike Java, Scala does not have primitive types. And it does support a concept of static. So we are going to see that later, how static entities are achieved in Scala. And obviously there are improved support like traits, which are very similar to Ruby modules. We're going to see that later as well. And by mixed paradigm, if you look at the functional part, we see that, it supports functional programming. We are going to look into the features of functional programming later in the course, maybe in the next module. And, there is something called pure functional programming. So obviously, Scala is not a pure functional programming language, unlike Haskell or Erlang. So, and I'll tell you why, later when we are doing pure functional programming languages. So Scala supports also actor libraries which allows both mutable and immutable variables. So that means you can use the actors library to create actor-based concurrency models. So people who are interested in working on actor-based concurrency models can use the actor libraries of Scala. So actor-based concurrency is a type of concurrency, in computing. So I'm not going to get into that, but if you're interested, you can just Google on the internet and read what is actor-based concurrency. And we're going to see later that in functional programming, functions are first-class citizens. So this is very important. This is a very important term, first-class citizens. Functions are first-class citizens. So this phrase basically means that, a particular function or a particular, in Scala or in any functional programming language, a function is just like a variable. So that means, you can actually pass the function to a method. You can pass it as parameters to methods. You can return it as values from methods. That's what it means. So by first-class citizens, I mean that you can actually pass functions as variables to other methods. So it just behaves like a particular variable. So you can pass it as parameters to functions. You can return it as values, and you can assign it. You can assign it to another variable, and then call it. Okay. So we're going to see all these things. These are very exciting things about functional programming, and I'm going to teach you how you can do that. Okay. And also Scala has a concept of closures. So closures we are going to see later. It is very similar to Python and Ruby concepts of closures. So people, anyone here know what closure is? If you don't know, it doesn't matter. I'm going to teach you later what closures are. Okay. So that's about Scala. Now let me tell you how basically Scala works. Okay. So one of the major reasons was, developers were looking for flexibility in languages to improve their productivity, because some of the languages they were becoming very heavy in terms of the compiler, in terms of the code size. So they were looking for a lot of flexibility in terms of data typing, in terms of other operations, and that's how scripting languages like Python, Ruby, then Groovy, Closure, all these things became very popular. And obviously, based on what we had learned from scripting languages, the other more optimizations were done in the existing languages. So in Scala, basically, Scala is a JVM language. So how Scala works is that you have a Scala code, which you give it to a Scala C compiler, and that generates bytecode. And this bytecode is the format is exactly the same as the Java bytecode. So this bytecode, what you see here, it is basically a Java bytecode. And then you can load the Java bytecode on any JVM, and you can just run it as any Java program. So basically, just remember that any Scala code, whatever you write, finally it is when you compile it, it breaks down into Java bytecode, which basically runs on any JVM. Okay, so it's actually 100% JVM compatible. So that's how Scala works. So whatever we have done so far, any questions you have, any doubts you would like to ask me? Okay, and these are the frameworks which I told you which are very popular. One is called the Play framework. It's used for web development. Then we already have Spark for in-memory cluster computing. And then we have Akka, which is actor-based concurrency framework. And you have some modules of Neo4j which have Scala wrappers, as well as there's something called Scalding, which is a MapReduce framework on Scala. So there are a lot of things coming up, and even if you have the latest versions of Apache Kafka, that also has Scala APIs for developers. So here's James Gosling. He's saying that if he were to pick any other language, any language other than Java, it would be Scala. So looks like he also likes Scala. Okay, so let's quickly now time has come to write some code. Okay, this particular VM which I'm using, this VM is already there in your LMS. You can download this VM and install it on a virtual box or on a VM player. And this particular VM already has Spark, Hadoop, Scala, and all the IDEs. Everything is installed there. So you can just download and start playing around with it. Okay. So let me, Scala basically comes with something called a Scala shell. Okay. So if you, people who have worked on Python, anybody who has worked on Python? Okay, Rao is asking me, is this VM different from the Hadoop VM? It may be different because in Hadoop VM, Rao, it has a bunch of other stuff involved also, like, obviously whatever course, whatever they teach you in the Hadoop course, those things are, installed. But it's better to install this because it just has the Hadoop and the Spark and Kafka and these things. So it's not very heavy, okay? So its choice is yours. Just check, in that particular VM, if the Spark is already installed, then you don't need to work on. Then you can just continue working with the VM. Else you need to get this VM. Okay, so anybody worked on Python? Anybody knows Python here? Okay, basically, you see, the thing is that Python gives something called a shell. Okay, so there is a shell called Python shell where actually you can do quick stuff. Like 1 + 2 3. So there's a Python shell. Okay, so it takes you to there, and you can do quick computations. You can write code, and test your stuff. And once you're comfortable, you can actually write it in a source file, save it, and then run it as a Python program. So similarly, Scala also gives you a Scala shell. So this is the typical Scala shell. And these type of shells are called REPL shells. Okay, just remember that these are called, REPL shells. Okay, REPL means, read, evaluate, print, loop. In computer science, REPL means read, evaluate, print loop, which basically means that you type the program, the expression is evaluated, and the output is printed, and this loop continues. So that's what the REPL means. And here we have an REPL shell for Scala, and so this is the REPL shell we have. And here you can write code. You can quickly test your code. You can save the code, and then once you're comfortable, then you can start writing it in the IDE. We usually, in the production code, we usually write code in the IDE. But when you're doing quick proof of concept, or if you just want to showcase something, or if you just want to see it for yourself, just want to do a quick test, then you can do then the shell is very, very helpful. Now in the shell, you can do a lot of stuff. Okay. Yes, Rao, Eclipse can be used for Scala, so you can use the Eclipse IDE for Scala. That's absolutely fine. And I'll tell you how, you have to use the Scala Eclipse IDE. So this is the Scala IDE, and you can just type help and see all the commands which are available here. Okay. And we are going to use the shell for a while before we go to the IDE. Now remember one thing is that I told you that Scala is not an interpreted language. So Scala is basically a compiled language. So that means unlike Python or Ruby, there is no interpreter for Scala. So the Scala language is completely compiled language, just like Java or C++. So what happens is whatever code you write in the shell, that gets converted to a class file, and that code is executed. Okay, so don't think that the Scala shell is like an interpreter. It's not an interpreter. So whatever code you're typing, actually at the background, an intermediate temporary class is generated, and that code is executed. Okay, and you can see the Scala version here. So whatever Scala you are using, so we are using 2.10.4. So you can see this version here. Now you can use the Scala as an interpreter as well, and as a calculator. So you can do things like, let me show it to you. So you can go to the Scala. So you can just say 10 + 2. It prints 12 here, and then you can say, you can do complicated arithmetic also, 9 into 4 into 3 + 2. So all these things also you can do. And now what I'm going to teach you is I'm going to teach you how you can declare variables in Scala. Okay. Now there are this is a little bit tricky, but just pay attention to me and see what I'm doing. So when you create, there are two ways you can create variables. You can declare variables in Scala. One is through using the keyword val, and one is through using the keyword var. Okay. When you use the keyword val, you actually declare an immutable variable. So immutable variable means that it cannot be changed. So just remember that. And var means it's a mutable variable. So which means it can be changed. So var, there are two ways you can declare a variable. Either you can declare it as a val, which is called a value, or as a variable var, which means it's a mutable variable. It can be changed later. Okay. So that's how you declare. These are the two keywords you use. So if I say declare X, and this is how you declare a variable. So Shailaja, you are right. You can see it as, you can view it as a constant. And the way we declare it is, you can write val here, then you can give X here. That's a variable name. Then you have to give a semicolon. Okay. Yeah, sorry, you have to give a colon here, and then you have to give the data type, int. So integer, int. For float, you write float. If it's a string, you write string. And then you declare, and you have to give the value here. Okay, you have to initialize with the value. So then it becomes an immutable variable. Why it's immutable? Because now if you try to change the value of 10 to 11, it's actually going to give you an error. Okay, it's going to say reassignment to val. So that means val is constant, you cannot change it. On the other hand, you can, if you declare it as a var, okay, then basically you can make it mutable. So that means this is perfectly mutable. You can change the values. You can do whatever you want. Okay, so these are the two ways you can declare variables in Scala. And also remember, you declare the data type. So you can declare data type like string, and you can write. So this is declared as string. Similarly, you can declare float. So this makes it, it's all the same. So you can declare it as a float. You can declare it as double. You can declare this as boolean. So this becomes true. So various things you can do, okay, with this. And these are the variables which you declare. Clear, all of you, how you can declare a variable in Scala and what you can do with it. So immutable types, is this clear to you? What is the difference between var and val? Now there's another interesting concept in Scala, and which people usually misunderstand, is that even if you don't declare the variable type, if you just write it like this, then basically Scala basically figures out the data type. So since you're already writing true here, so Scala knows that this is a Boolean type, and it converts X to Boolean. So if you do like this, it says that X is Boolean. So please don't think that Scala, if you don't write the variable type, it does not become like dynamically typed. A lot of people think that just because I didn't write the variable type, the data type for the variable, it becomes like a dynamic type. It is not dynamic type. It is called type inference in Scala. So that means based on what the value you're initializing with, it takes a smart guess. Okay, so if you write something like this, so it knows 10 is an integer, so it will make it as integer. So if you write 10.9, it's going to actually make it double because you did not say anything. So since there's a floating point number, so it converts it to a double. But if you explicitly want it as float, then you have to write it as float. Okay, so then it becomes float. So if you explicitly want it float, you have to make it float. Or if you don't give any data type, then by default it becomes double. So this is called type inference in Scala, and please remember this. Okay, and this is, let me introduce you to Annie. Annie is going to ask you a lot of questions from time to time, so just make sure you oblige her. So here's the first question Annie's asking you. Annie's asking that, is the Scala REPL acts like a Scala interpreter? Is this true or false? Can you tell her what is the correct answer? Does the Scala interpreter act as a REPL act as a Scala interpreter? Yes, you're right. The answer is false. Very good. Well done, class. So the answer is false because Scala is not interpreter. Scala is a compiled language. So even if it looks like an interpreter, internally the code is converted to a class file, and the code is executed. So the answer is false. Okay. Can you answer the next question? Scala supports primitives and REPL classes. Is this true or false? What do you think? Yes, you're absolutely right. Scala does not support primitive and REPL classes, so the answer is false. Okay, so now we saw how we can do variables and how we can declare mutable and immutable variables. So that's exactly what's written here. If you want to create read-only constants, you can declare it as a val. This basically means you have Java as similar to Java's final variables. Similarly, if you have var, it's a read-write, and that means it's mutable, and you can reassign values to it. And obviously, I told you about type inference. So that means if you don't give any type, it's going to figure out what it is, and it's going to make a guess. Okay. So just remember that Scala is statically typed language. Okay. Okay. So it's basically statically typed language. Now let's talk about expressions and blocks. Okay, so this is another very important thing which you keep in mind. So say for example, I write val x equals to, and in this curly braces I can declare actually values like a equals 100, then I can write val b equals 200, and then I can say a plus b. Okay, I can do this. Now if I do this, a plus b, then the value of x actually becomes 300. Okay, so here what happens is you can write expressions inside curly braces, and just remember in Scala, so the last expression, whatever you're writing, the last expression, that thing is assigned to the variable. So that means if you have something in a block, so if you have something in a block, so whatever is the last expression you're writing, so the last expression is basically returned from the block. And here, since we're assigning it to variable x, so this becomes kind of a return value for this block. Just remember this is a very important property of Scala. You can actually use it in several places, which I'll show you later. And when you're writing instructions in the same line, you can actually use the semicolon. Otherwise in Scala, the line delimiter is basically a new line. So that means in Scala you don't have to give semicolon like C++ or Java or C. If you give a new line, so that becomes a new instruction. But if you're writing the instructions on the same line, you can actually use a semicolon. So I can write the same instruction without using the semicolon. So I can actually write something like this. I can give a curly brace. I can say val a equals to 100. I can say val b equals to 200. And then I can say a plus b. I can do the same thing. Okay, this and this is exactly the same. Here basically I just wrote it in separate lines, so that's why I did not have to give semicolon. But here, whereas in x I wrote everything in the same line, so that's why I gave a delimiter to the instructions, so which is the semicolon. And obviously the last expression becomes a return type of this particular block. So that's how basically Scala works, and this concept is very important for functions and methods, which we are going to see later. Okay, clear all of you with this piece of code? Okay, good. Now let me show you something called lazy evaluation. Okay, it is a very, very important concept in Scala again, and now you will understand why Scala was used in Spark, to write Spark. Now say for example I declare a variable x equals to 1000. Okay, now the moment I declare it, the memory is initialized, and now we can see that x is equals to 100. So now if I say x into 2, it prints 200. Okay, now say for example, let's understand the business use case, that how what is the problem with this kind of stuff. Now say for example, if this x was a list, okay, if this x was a list of say 1 million numbers, and I want to multiply each number by 2. So if I just declare this x list equals to 1 million numbers, it's going to take a lot of memory, right? And so the thing is that upfront, when I declare the variable, it's going to take a lot of memories, even if I don't use it. But if I have a requirement that I just want to use it when I want to use it, so that means it's kind of load on demand or just in time. So then I can actually make it as lazy. Okay, so I can write lazy here. So you see the difference between this declaration and this declaration. Here when I declare it, it straight away shows 100. But here it doesn't show 100, it just shows lazy. So that means actually no memory has been allocated to this particular variable. And these are very, very useful, when you're doing very large computations. So that means upfront, you don't want to commit to any memory. You only commit to memory when there is actually some computation you're doing. So that means when I actually do an x into 2, that is when, the x is going to get initialized 200 and the value is going to be computed. Okay. So this is a very important feature of Scala, and many functional languages has this feature. It's called lazy loading or on-demand loading, and this becomes very useful when you're doing large computations. So when you don't want to upfront allocate the memory, but you just want to do it on demand. And these are very, very useful for cluster computing as well, because in cluster computing, if you have various computers in your network, and just imagine, if you just want to load, say for example, a list with 1 million values, and you want to send it across all the clusters, it actually takes a lot of memory, lots of network which happens. So rather than that, what you can do is you can just declare it here, and and it will be actually sent when you do some computation on it. Okay, so it's like that. So it's always on demand. So only when you're doing the computation, that's when the value is initialized and sent to all the computers, and the computation starts. So that way you save a lot of memory, you save a lot of network bandwidth, and you can do a lot of optimizations. Is this concept of clear lazy to all of you? And that's one of the reasons why Scala was chosen to write this cluster computing framework Spark, because that way they could optimize it. Because otherwise if you just declare upfront these memories are allocated, and that becomes a big problem. Okay, Praveen is asking me that can you give me an example with multiple values of x? Yeah, sure, I can give you, but the thing is you still haven't learned collections, so I'll just give the example, but maybe later on you will understand what I'm trying to write here. So I can just declare a list, a list of, say, 1 to, say, I can say 1 to 100,000, and I can say, so here I've generated a list, of 1 to 100,000, and so it's basically 1 to 100,000. I've generated a list. It's a list of integers with so many values here. Okay, upfront, so many 100,000, integers allocated. But I can optimize it. I can just optimize it, and now say, for example, if I want to find the sum of the list, so I can say, don't worry about the syntax, that's what you're going to learn later. Now you see that if I want to find the sum of all the integers in the list, I can just do this, and this is the number. So you have 100,000 numbers here, but just imagine if you have millions and millions of numbers, it will be very inefficient, and you will straight away allocate a lot of memory to it. So what I can do is I can just declare it as lazy. So then it becomes that when you actually do some computation, so when you actually do a computation, that's when it will be loaded. So now if I do if I just want to find the sum of all the numbers, in that case you see that that time the actual memory is allocated. Okay, clear, Praveen? Okay, Srinivasa is asking me, does definition will store in memory rather than process immediately? Yes, you're right, Srinivasa. So basically the definition is stored in the memory. It is not, the instruction is not immediately executed, it is just stored. The instruction is executed only when the first time when you reference the variable through some computation. So when you actually do some computation, that's when the value gets referenced. So this is a very important concept, lazy. Just remember this, because when we are actually doing Spark architecture, you will see that this is one of the cornerstones of the Spark implementation. So maybe you can just have a look at this example, and if you have any questions for me, you can ask me. I'll just give you just 30 seconds or maybe 1 minute. Just take and just recollect whatever we have done in the last 1 hour, and see if you have any questions or doubts, you can ask me. Okay, Arvind is asking me that could you access the value without any computation? Arvind, you can't do that. The moment you access the value, it's actually you are accessing it. Okay, so in that case, it's immediately the value will be loaded into the memory. So the moment you actually access the value, the definition becomes a manifestation. Clear, Arvind? Okay. Okay, Venkat, if you have joined late, don't worry, the recording will be available in the LMS. So you can just check the recording, and you want to understand what is this syntax reduce I'm using. Don't worry, I haven't explained it to anyone, because it's just an example I was giving, but we are going to learn about this syntax when we are doing functional programming. So don't worry about it. But this reduce just takes a sum. It finds out the sum of the list. Don't worry about the syntax, but this is what the reduce function does. Okay. And you can use lazy for for file loading, anything. So if you're loading a file, you can, for any kind of operations. Okay. Okay, Rao is asking me, is this reduce function similar to the map reduce? It's not similar, but conceptually they are the same, because when you're in the reduction phase in the map reduce, whatever happens in this function also the same thing happens. But conceptually they are similar, but they are not the same. Okay. Okay, Praveen is asking me if you want to apply some logic on individual members of the list. So for every member, it may load the list, right? Yes, you're right, Praveen. If you want to individually apply some computation to a cell in a particular list, you cannot do that. The moment you access the list, the whole list will be loaded into the memory. Okay? Right. So now we are going to see some if-else statement. This is, I'm not going to spend too much time on this because I think all of you know this. The thing is, you can, this is a typical if-else structure. So you can, and the boolean, you can give a double ampersand for and or 2 pipes for a logical or, and you can give boolean operations like this. Okay. Vimala is asking, is this lazy concept similar to the pig DAG concept? Absolutely similar, Vimala. It's the same concept, which we are going to use in Spark, and they also in Spark also there's a concept of DAG. So the DAG actually is nothing but a lazy initialization. So Vimala, it's the same thing. Okay, good. You know that at least. That way you'll be able to relate. Okay, so that's the if-else part, and now we're going to look into some important stuff called loops. Okay, how we loop a particular iterations. So say for example, I declare a variable str called test. Okay. So here we have a test, and just remember that every iterator or every collection has an implicit function called for each. Okay, so the for each, what it does is it basically inside the for each you can actually give a function. So what happens is this is what function programming is all about. I told you that function programming functions are first-class citizens. So there's a function called println. Okay, so this println basically is just like system.out.println in Java. So it prints on the console, and you can pass this function as a parameter to another function called for each. And so what this for each is going to do is it's going to print every element of this collection using this println function. Okay, so that's what the for each does. And I told you that for each is available to any collection in Scala. And string is also a collection because you can see a string, you can view a string as a sequence of characters or as a list of characters. So you can apply this for each loop to any collection. So that's what first-class citizens in action. So that means you can pass this for each basically takes a function, and you can pass any function here, which basically, and here is the print function which just prints without a new line. So the test is printed. And we are going to see the more of this for each loop, when we are doing lists, when we are doing, when we are doing any kind of collections a little later, okay? But just remember this particular function, for each. I hope it's clear, right, what for each is doing, and you're able to understand this. Okay, now we are going to see the for loop. The for loop in Scala is a little bit different from the for loop, in C, C++ or Java. So the for loop is written like this. This is the general syntax. So here you write the argument, and then you give an operator like this, and then you give the collection here. Okay, and then you write whatever code you want to write. So this is the typical way you want to declare a for loop. So here, say for example, I can write something like this. So here, what this particular for loop does is, just pay attention, is that I have a list, from 1 to 5. So if you just write 1 to 5 on the, so it basically generates a range of numbers from 1 to 5. So this is again a collection. It's part of the collection. So what it does is, it takes each element, and this particular operator, assigns each variable, each element from this collection to I, and this I is printed. Okay, so now you have from 1 to 5, you can print each of the numbers. So similarly, and by default, the numbers increases from, by 1. So now if you just want to run the loop in the opposite way, if you just want to say, 5 to 1, so that means instead of printing 1, 2, 3, 4, 5, you want to print 5, 4, 3, 2, 1. So obviously it's not going to work, because by default, the loop increases by 1. So then you have to say by -1. Okay, so this basically means that the loop counter is going to decrement by -1. So just remember this particular syntax of the for loop. Okay, here, Rao is asking me what are this rest 9, and then I'm saying rest 5. What are these stuff? No, these are temporary variables which are created. Okay, so So say, for example, when I write this, I told you that, this code is converted to bytecode and it's loaded in a class and executed. So the return value is stored in a temporary variable called result. It's basically a result, result, and it's a serial number 1, 2, 3, 4, 5, like that. It's a running counter. Okay, and then so that's what it's a temporary variable in which the variable is stored. Clear now? Okay, Shailaja is asking me, can I have any other increment? Yeah, why not? You can give -1, you can give -2, you can give anything you want. So this just prints the odd numbers. Okay. So basically, it just prints the odd number. Similarly, if you want to print the odd number in the reverse way, so you can just say, 1 to 5 by, you can say 2. So it will print. Clear, Shailaja? So you can do by anything, it's just like a for loop counter. Okay, Srinivas is asking that, just a quick question, can I use -1 for each? No, in the for each, I told you that in the for each, you cannot pass, other than a function, you cannot pass anything, okay? So the for each only takes a function. And a for each, we usually use for collections, which I'm going to show you later. But usually for the general purpose for loop, this is what we typically use, okay? Okay, before we went to a break, Vimala was asking me that she was asking me this, okay, so let me write it down. She's asking me that what happens here, okay, so why is nothing been printed? So what do you think, Vimala? What is happening here? Others would like to try? What Vimala's question is that, this particular thing doesn't print anything, so what's going on here? Yes, Rao, you're right. Vimala, any guesses? Does this make any sense at all? Because you're reducing the counter from 5 to 1, but you are incrementing it. Is this possible? Like, it's kind of a contrary condition. So I just tell you, it's like telling you that can you climb from from first story to the third story by climbing down? Okay, so this statement by itself doesn't make any sense. Got it, right? It's not an infinite loop. It doesn't make sense. It's like telling you that, Vimla, you go from first floor to third floor by stepping down. I don't know how is that possible. If you can only go by stepping up, right? By stepping down, you cannot go from the first floor to the third floor. It's like that, okay? So nothing will happen actually because the condition is purely false, so it cannot do that, because the range is from 5, 4, 3 to 1 and you're trying to increment it. So obviously this whole condition is false and that's why this is never printed, okay? So clear, Vimla? So it's kind of a false condition, okay? Okay, right. So that's, that's about, so no, Prashant, we won't have any exception. There's not an exception condition. It's just that the condition is false. So obviously it's not evaluated, okay? So that's why, it never happens. Okay, and, you can do inner loops, there's a one level loop. You can also do 2 level loops like this. So then you can run a loop from say, 1 to 5, and you can run j from say 1 to 4, and you can print something like this. Okay, so you can print it as a tuple ij, okay, and so it just prints the tuples here. Here's one syntax you should pay attention to. See, inside the string, okay, inside the string I'm referencing I and j. So you can reference variables inside a string, but you have to just prefix it with a $. Okay, so if you prefix it with a $, so Scala knows that this is actually a variable which needs to be substituted at runtime. And how it is to be substituted? As a string. So that's why I put s here, okay, as a string. If you want to interpret it as an integer, so you can give a d here also, no big deal. So but the d is not going to work because you're putting it inside a string. Okay, so that's why you have to put it as an s. So that means just convert this integer to a string and substitute it in this particular string. Okay, so if you want to embed variables inside strings, you have to put a $. Before the variable name, and just outside the quotes put an s. So which means that convert these variables to strings and then embed them. Clear? So that's how you do this. Okay, so this is how you do two level, and you can go up to 3 level, 4 levels like that. There's another important condition which I would like to tell you, and these are typically guard conditions. Okay, so now is this loop clear to all of you? Is this particular loop clear to all of you? Can I have a quick poll on whether this is clear or not? Okay, so this is how I print my particular loop. Now I can write the code like this also. Now the thing is that what if I just want to print only when I equals to j. Okay, so I can write the loop something like this. Okay, so I can write the for loop, then I can write an if statement, if I equals to j, then I can say print this. Okay, and so then it will just print for I equal to j. Okay, now this particular loop is a little bit inefficient in the sense that the iteration basically happens here, because why the iteration happens is because for every iteration, it basically goes inside the loop, does this checking, and based on whether the checking is true or false, it does the computation. But in Scala, you have a very nice feature, and the feature is that you can directly write the if. If you have a guard condition, these are called guard conditions. You can directly write the if, in the for itself, and then you can just say println. You can just do this. Okay, this is very, very efficient than this particular piece of code, because here in the iteration itself, it can do a check, and based on whether the condition is true or false, it proceeds with the loop. Okay, so you can actually put a guard condition here, and these are very important, when you're doing any kind of processing in your business logic. So say for example, if you have things like, if you write a loop like for, say for example, for every customer, okay, from the customer list you're taking, and suppose you're doing some processing, okay, you're doing some processing of the customer, and you only check that you only enter the loop. You can say that if customer dot is active. So you can do something like this, like if the customer is active only, that means he's not hibernating somewhere in Siberia. So if that's the case, then only you proceed with the processing. Otherwise, you can just keep on going through the customer list. Okay, so all sorts of predicate you can add here. So this one business use case in practical application I showed you, which is very, very useful in linear processing. Clear, all of you? Did you all understand this? I want you to understand this thing very clearly, because I'll be using this in Spark a lot, and it's important that you all understand this, as well as the lazy thing. Okay, the lazy is very, very important. That's the cornerstone of the Spark architecture, and I want all of you to be equally competent on this. Okay, Praveen is asking me, does this process have any meaning having if and for? No, if basically means that if the condition is true, then only the code inside the for loop will be executed, else it will be skipped. Okay, Praveen. Okay. What do you mean by Praveen? Any naming? Oh, you mean does it have any name? Is that what you mean, Praveen? Yeah, it's called a guard condition. Okay, it's called a for loop with a guard condition. I said that when I was introducing you to this. It's called a for loop with a guard condition. Okay, Srinivas is asking me. Okay, no problem, Praveen. It's quite possible because you don't see me. You're hearing my voice. It's quite possible you can miss out things. So no problem. Okay, Srinivasa is asking a little bit more on is active. No, is active means that I'm just checking whether the customer is active or not. So say for example, I just want to send some bunch of offers, or some free gifts to my active customers. So if only the customer is active, then only I do the processing from the customer list. Else I just skip. Okay, so that's what it's just a simple example I wanted to give you. So instead of is active, you can have any other things like whether is the customer a premium customer, or is the customer staying in some particular part of the world. Okay. Yes, Srinivasa, it's right. I'll just write it down in case there's a problem with my accent and people don't understand. It's called a for loop with a guard condition. Okay, so that's when you write a for with an if inside. Okay. Yeah, yes, Srinivas, that's right. So no, it's better to write it down at times because English has many homonyms, so a lot of words sound similar. So it's better to write it down so that we all are on the same page. Okay. Okay. Good. So one sec. Let me see if I've answered all the questions. Okay. Now Erwin is asking that can you use this if in for each? Yes, we can use this in for each. I'll teach you later, Erwin, when we are doing functional programming, because now I have to write a lot of syntax which you may not understand. Plus, I want to give you some more fundamentals on functional programming before I jump into how on the usage. So I don't want to rush into that, so we'll do that in the next module. For now, just stick to this example, okay? But I'm going to make it more complicated later on, and I'm going to tell you exactly how you should do it in production code. Okay, that's what you should do. So, but since today is the first day, and I'm just taking it a little bit easy, okay? Okay, Rafaela is asking me that, so just to clarify, if I put the if condition inside the for loop, it's always more efficient. Yes, Rafaela, it's right. If you put the if condition inside the for, so that's called a predicate. If you put that predicate inside, it's always much more efficient, than putting the predicate outside the for. Okay. Okay. Did I get your name right, Rafaela, or you want me to call you Ma, Rafaela, or just let me know? Okay. Inderjeet is asking me, can you give us one more example with the guard condition? One more condition with the guard condition. These are typically, typical checks, which you want to put inside. I'll give you another example. Very, very simple example though. So say, for example, if you just want to print, maybe even numbers from a list. So say, for example, you have this for loop, running from 1 to 20, and you just want to say that, if I, modulo 2 equals 0. So that means only if the number is, even, then only, you print the number, else you don't print the number. Okay. So that's basically an example for even. This is an example for odd. Clear, Indrajit? Yes, Srinivas, I'll tell you, which is more efficient. I'll tell you. Like here, I told you what is more efficient. So as I go along, I'll tell you what is the code you should write and what is the code you should not write. Okay, so that I'll go as I go along. So now let's understand one more thing. Okay, so here, since I already gave this example here, so here what we are doing here is, we are collecting we are just printing a list of, we are printing all the even numbers from which occurs between 1 to 20 inclusive. Okay, so this is what we are printing. Now, if my requirement is that, I want to collect it in a list. So instead of printing, because see, in actual program, you don't print, right? You collect the results somewhere and then you do some further processing on that. So instead of printing, because printing is pretty silly, you actually don't do that in real life coding. So maybe what if you want to collect all the numbers here? Okay, you want to just collect it in a list and send it back. So for that, we have something called a keyword called yield. Okay, so you can use the keyword yield. So in yield, what happens is yield is a keyword, and so here basically the output of every for loop iteration is stored in a list. Okay, and it is basically sent as a vector. So you can actually collect this, inside, a vector, and now you have x, which is, so instead of printing, you can just collect it in a vector, and then you can do some functional computation later on. So remember this, if you, in case you want to collect some operations somewhere, so you can actually do this. So say, for example, that previous example I gave you about that customer thing. Okay, so we were doing that, if if the customer for the customer list. So if the customer is active, then I can yield the customer. Okay, so then basically I'll have so then what I can do is I can actually have a list of active customers. Okay, if you want a list of active customers, you can do like this. So you can go through the list of all the customers, and only if the customer is active, then you keep storing it in a vector, and that you assign. So then finally you have a vector of a list of active customers. Okay, so that's a practical application of typically of using an yield. Okay, so just remember that in the yield, the results of the for loop. So just to summarize, in yield, the result of each for loop, iteration is stored in list. Okay, and this is a vector to be precise. And this is very useful. I showed you one typical example where you can use this. Clear, all of you? What yield is, what it does. Okay, good. So all of you are clear with this. Now let's understand functions. Okay, so now we are going to talk about functions in Scala. How you define functions. So from the morning, we have seen variables, keywords like val, which means an immutable variable. Okay, Srinivas, yes, you're right. Yield is only usually applied with the for loop. So obviously, since you're collecting the results in an iteration, so obviously, it goes hand in hand. Okay, from the morning we saw val, which means if you want to create immutable variables, if you want to create mutable variables, you use var. Now we are going to see how we can define functions. Okay, so here is the standard syntax for functions. So you write def, then you have the function name, then you have the function parameters, and then you have the return type, and then you write equals, and then you give the braces. Okay, and this is where you write your code. So this is the standard typical way we write the function. So we write the function name, the function parameters, and the return type. So let's look at an example. So I'm writing a function to calculate the area of a rectangle. So I can say length, which is an integer, or let's keep it float. Okay. So this is my length, and this is my breadth, b, which is again a float, and it returns the float, the results, and I can write length into breadth. Okay, so that's my function. So if I want to write a function to calculate the area of a rectangle, so I say def, the name of the function area rect, then I give the parameter list. So I write the parameter name, then give a colon, and then give the data type, and then with the commas, I keep on writing. And finally the parameter list is over, and then I give a colon, and then I specify the return type here. Then I write an equals sign, and then within braces I write the code. Now I told you, in the beginning of the lecture that anything written inside the braces, the last expression here, it's the only expression here, but usually the last expression becomes the return type. So here basically, this becomes a return type. So actually in Scala, you don't have to write something like this. You don't have to do this, unlike Java or C++, because the last expression by default becomes the return type, becomes the return statement. So the length into breadth is defined. Okay, so this is the one which we have here. Let's paste it, in the console. Oh, this was float, sorry. So then I write length into breadth. So my function is defined. So I have a function called area rect, and the parameters is length and breadth, which is of type float, and the return type is float. Okay, so now I can call this function like area rect, and then I can pass 10 and 9. It sends 9, or I can say 9.5, and here I can say 10.23. So this, since it's taking float, I cast it to float. So this is the, and here I'm writing f because by default it sends it as a double, but since my function is only taking float here, so I write f. So f basically means that treat this number as a float. Okay, so this is my function which I have written here, and you can write various functions. So you can write even, so this particular function is returning a float. Okay, so you can also modify this particular function to not return anything. Okay, so say for example you don't want to return anything. In that case, you write unit. So when you write unit, it means that your function doesn't return anything. It's like a void function. Okay, so you can say println if you just want to print the area. So then you have a function called area rect, and now if you called, so it just prints the number. So here the function is not returning anything, it's just printing. So then the unit basically means that the function doesn't return anything. It's a void return type. Okay, clear all of you with this unit stuff? how to define a function. Okay, now that all of you know that, can you quickly tell me, can you write the code for me if I want to check a function, say whether the number is even or not. So if I want to write a function called isEven number, so I just want to check whether the number is even or not. Can you tell me how the function is going to look? And here I'm going to pass a number, so I'm going to pass it's going to return a true or false, whether it is an even number or not. So can you tell me how I'm going to do this? Can you write the code for me? Let's see, with whatever you've learned today. Okay, let's see what things we have here. Brilliant, Vimala, brilliant. Okay, Reena, let's see, Reena, what you're doing. You don't need that if, Reena. So without the if, it's fine. Well done, Reena. Yes, your code is going to look something like this. Well, let's see what Praveen is doing. No, Praveen, this code is not going to compile. Okay, I'll write the code. I have all sorts of stuff here. So this is the best, which I can write. So I'm going to write it as isEven, okay? And this is the number, and this is the Boolean. And just here I write number modulo 2 equals to 0, because this expression is a Boolean expression, right? This is a Boolean. This will evaluate to true or to false. Okay, so in that case, you obviously have, there's a Boolean outcome. So obviously, this will be either true or false, and that's the best way to check it. Well done for the people who had written the code like this. This is the most efficient and the best code which you can write. Okay, so just write this, number modulo 2 equals to 0, because this by itself is a Boolean expression, so it will either evaluate to true or false. Okay, Shailaja, what have you done? Yes, you're right, Shailaja. It's the same stuff which you have written. Okay. Okay, now Praveen is asking me that if I want to use if, how I am going to do it. Okay. So the thing is that this is the best stuff, but if you want to use if, okay, I said no, I want to use if, even though it's not the best. So in that case, you have to write like this. Okay, you can write if number equals to 0, then you say true, else you say false, and then you close the number. Okay, and then you say. So this is also fine. Okay, thanks for okay, Praveen. So. But you don't need to write like this, okay? So you actually, this is the best way you can write it, okay? So, but it's okay, it's good to learn. So this is also okay. So one thing you notice here that we don't have to write return here because that's really not required, okay? So that's one of the fuzzy things about this language. Okay, good. So I think all of you have learned how to write functions, and this is all what is there, in functions. If you have understood this basic part, that the basic thing is that how you declare a function with a parameter list, what is the return value, and how you're going to return the value. I think you've learned that. There's nothing more to it. Now it depends on what kind of functions you're writing and what you're doing there. Okay, but otherwise it's absolutely fine. Okay, now one more thing which we are going to learn here is about arguments. Okay, so let's go back to our function, which we wrote here. Yeah, Praveen, I'm going to tell you that a little later. Okay. So let's go back to our. Okay, Srinivasa is asking me what is the issue with my syntax. Okay. One sec. Let's see what you've done. No, Srinivasa, this stuff is not going to work, right? Will it work? What do you think? No, I think the best thing is just check it out in the console, because I don't want to sit and validate syntax because that's going to really waste my time. So, but if you have any fundamental doubts, you can ask me. I think I'll be more than glad to help you. Okay, good. So let's go back to the area thing, and I'm going to teach you something called default arguments. Okay, so I'll just keep the function definition simple so that we can focus more on the learning and rather than get stuck with data types. So here's the function I have, an area rect. So I can call this. So this is how it works. Now you can keep default arguments. Okay, so here by default arguments I mean that you can actually set, say, breadth to 10. Okay, if you do that, then when you call length, so you just have to pass the value of length L as 10, because breadth by default will be set to 100. Okay, so that you can do, and in case you want to override the value of breadth, you can give 12 here. So instead of 10, 12 will be used. So now it's 120. Now there are a couple of rules, in setting default arguments. The thing is that you cannot set default arguments like this. Okay, And this is more or less true for all languages. So you cannot do like this. If you do like this, there will be a lot of confusion. So say for example, if you define a function where the first argument, the length you have defined, defaulted to 0, and then the breadth, you haven't defaulted to anything. Now when you try to call it, it basically complains, because it really can't figure out, what is this 10? Should it assign the 10 to the length, which already has a default value of 10? Or should it assign, 10 to b, which is the breadth? So then the compiler complains. One way you can solve it is that, you can write b equals to 10. Okay, then in that case it will work, because it knows that L already has a value 10. B should be 10 then. Okay, so you can do that and you can hack your code. But if you don't do this, then it's going to complain. But this kind of coding is actually a bad practice. I don't recommend. And what Scala best practices recommends is that when you give default arguments, make sure that you give the default arguments at the end. Okay, so don't give it at the beginning, but give it at the end. Okay, so that you don't land up writing things like this. Okay, but having said that, you can have a default argument in the beginning, and you can resolve this by actually telling which argument is what. But that's not a good practice. Okay, even though the compiler allows, it's not a good practice. The good practice, the best practice, is that you define the default arguments at the end of the parameter list. Okay, and then once you define like this, then you can call area rect. Then this works. Okay, it works perfectly. Okay, so let's start. Now, Scala has a rich collection of, it has a very rich library of collections. So the collections, which we are going to primarily focus on and which are very important for you are arrays, array buffers, maps, tuples, and lists. And in most of your career in the Spark programming, you're going to use, either of the 5. And they are very, very important. So I'll tell you how to use them. So first thing is, we're going to use is an array. Now an array is of fixed size length, so you cannot change the size of an array. And this is how you, declare an array. So before we, use the class, let me show you the class first. So if you go to the Scala docs and type array, so you will see that this is the array you've got in the Scala package. And these are the methods, it has. Okay, so you can go through the methods later on and figure out what are the things you need. So let's use the array. So you declare the array as new, then you write array. And the thing is that, whichever package, is in the Scala package. So whichever class is in the Scala package, you don't have to import them. So it's just like the java.lang classes in the java.lang package. They're implicitly, available to all the classes. So similarly, Scala, whatever classes come under Scala, they're also available to the compiler. Okay, you don't have to import them. Okay, good. So we write array, and then what you have to do is you have to specify what the array stores, because in Scala, just like Java or C++, you can only store homogeneous objects. Okay. So in this array, we are going to store integers. So you mention in square brackets integers, and then you have to mention the size of the array. Okay, so this is an array of integers, and it's going to store 10 integers. Okay, and all the elements are initialized to 0, and you can access the array, with they are always 0-based index. Okay, so you can see that the arrays are 0-based index, and this is how you access the array, with the normal brackets. And you can set the value to the array like this: arr1 equals 200. And now if you print the array, it will say 100, 200, like that. Okay, and if you want to print each element of the array, so you can say for each println, which you have already learned in the first module, in this module. So it's going to print all the elements of the array. Clear how you declare an array? So similarly, if you want to declare an array of strings, so you declare an array of strings, and you say it's an array of 3 strings declared to null, and you can initialize them to test and This is how you can go through it. Okay, clear? And the thing is, this is one way of declaring an array. New array, give the data type and the number of elements you want in the array. Or you can statically declare the array. So rather than giving anything, you can just write array and just write like this, an array, and give the elements inside it. Though we'll naturally, we won't be doing such things in programming because the data is usually inserted by a program. Obviously, we will never hard code the data. But in case you are testing something, just small things you are testing, you can also declare like this. Okay, so and then you can do like this as well. Okay, so both are valid. But usually this is statically declaring the array, which you'll really do in the program other than testing stuff. Most of practical cases you'll be declaring it like this. Okay. Now I would like to ask you one quick question. Is that, have you all understood this, whatever I have done? Is it all clear? Any questions you want to ask me? Okay, now I'm going to ask you one question. And the question is that, you see that the way I've declared the array, okay, I've declared the array as val arr equals to new array of strings element 3. Now this arr is a val, okay, so that means it's immutable, okay? You agree, right? The arr is immutable. And if that's the case, then how am I able to add, values? Similar to that integer stuff, okay? I declared the integer array as a val, and then I'm able to add elements to this, because yesterday we learned that val, it was immutable. So if that's the case, then how am I adding, elements to this particular thing? Any ideas? Okay, Rao is saying that the number of elements in the array is immutable. No, that is by definition, an array by definition, and the size is fixed. So that's not a big deal. But what I'm saying is that, I'm declaring this as a val. So how come I'm able to assign it? Okay, Praveen is saying that after initialization, you have assigned a value. So if you redo it, it may throw error. No, it won't throw error. I can again redo the stuff. It just work. It will work. So Vimla, it's not the size of the array, which is by definition size of the array. Once you declare, it's immutable. I'm saying that why is the ARR reference? It's still kind of, I can change values into it. Okay, thank you all for your answers. Let me give you the answer. Here the trick is that, when you declare objects as VL, as vals, basically the object reference becomes immutable. Okay, that doesn't mean the object is immutable. So you can change the object value, you can change the state of the object, but the reference remains the same. Okay, so you won't be able to change the reference. So that means the ARR will always point to this particular value, this particular array. Okay, so I can give you the example here. So say for example you have this array here. Now you cannot do this. So ARR will always point to this particular array of 1, 2, 3, 4, 5. You cannot actually now do this. Okay, you cannot write ARR now, 100, 200. If you try to do this, it will give an error. So that means this particular assignment, this reference remains constant. Clear, all of you? So remember that, when for cases of objects and containers. So the reference, it will always point to this particular array. You cannot change the reference. But having said that, you can change the value. That's very much possible. Okay, so just remember that fundamental difference between general objects and array. So for example, if I write x is equal to 10, so here what happens is, x is always pointing, always having a reference to 10. You cannot, change the reference of x from 10 to something else. And for this also, this ARR is always pointing to this collection array. Okay, so you cannot change the reference. However, you can change the contents of the array. That is quite possible. No problem with that. Okay. Yes, Rao, you're right. So individual elements can be changed by, by accessing the index. Okay. Okay, Praveen is saying that how do I define an array with a set of where the values are constants? See, Praveen, if you want to declare an array with the values as constants, then obviously you have to individually, you have to insert, value which are immutable. Okay, so, but generally by definition, it is not possible in arrays. That's the way Scala is designed. because I really don't get a use case that why you want to do such a thing. Because in a collection you're going to store values, so why do you want to store constant stuff in the collection? In that case, you can just keep that in a variable, right? So Scala actually does not allow this. Even Java does not allow this, because there's not really a good use case for this in business. Okay, so that's about arrays. Remember this. This is a very important thing. So now we go to something called array buffers. So the only difference between array and array buffers is that it has a variable length, so it can actually grow. Okay, so let's again take an example. I can declare an array, and you have to mention what you're planning to store there, and you don't have to mention anything in the brackets, the size. So basically you get an array buffer. What happened? Array buffer not found. Sorry, I have to import Scala collections dot mutable dot array buffer. Okay. So you have to import the Scala collection mutable array buffer, and then you can declare this array buffer. Okay, so we have this array buffer here, and then you can add elements to this array buffer like this. So 100 has been added, now 200 has been added, and you can also add like this as well. You can say 300, 400. So you can do like this. So now you have an array of. Okay, Shailaja is asking me a question. I didn't understand what's the question. Okay, and you can also, so we saw that this is how you can add, array elements to array buffer. And also, you can, if you want, you can straight away add, an array also to the array buffer. Sorry, plus here. So now you can, so if you want to add individual elements, you can use the plus equal to operator, and if you want to append collections, to the existing array buffer, you can use plus plus. Okay. Okay, Shailaja is, I'm just trying to understand what Shailaja is asking me. The scope of val, ARR, and okay, Shailaja is saying that she's trying to understand, Shailaja is trying to understand the scope of val and vars in terms of array. See, the thing is that, when you make an array val, can you hear, all of you, can you hear me? Yeah, okay. So when you make it val, so that means, the constant, the reference is constant, and when you make it var, so that means, the reference can be reassigned to another, to another array or something like that, okay? Okay, you want an example? Actually, I explained it to you. I don't know why you are still confused. Okay, so we have this array, which is array buffer. Now the thing is that, if I declare another, I cannot do this because I won't be able to, reassign it. I cannot write array buffer, so that won't be possible. I cannot do this. It says, reassignment is not possible. But if I had declared this ARR as val, then a reassignment would have been possible. Okay, Indrajit is asking me that, could you please explain result 5, that is result 15. Yeah, what we'll do is, let's quickly see the, array buffer class. So if you see the array buffer class, you will see a lot of operators. Okay, so you will see the plus plus operator. So what the plus plus operator does, is basically, it creates a new collection containing both the elements. So if you look into this definition, it says that, it creates a new collection containing both the elements from this collection and the provided collection. So that means what I'm doing here when I'm doing a plus plus. So basically it creates a new array buffer, and with the old values as well as the values which I'm providing here. Clear, Indrajit? So similarly, when you do a plus, so that means, what happens is you can append an existing collection to the ARR. So let's look at the plus now. So if you use the plus, it says that it appends a single element to this buffer and returns the identity of the buffer. Okay. And similarly, like just like plus plus, you also have minus minus. Okay, so this basically what it does is it's just the complement of that. So whatever elements are there that will be removed. Okay, whatever is there in the traversal. So I'll give you an example here. So here we added, this particular thing, 600, 700, 800. So this is my new array buffer which I have. I can write now, if you want to get rid of 700, 800, you can give like this. So now you see that, from the old array, 700, 800 has been removed. Okay. So I think that's what Carl was asking, that is it possible to subtract or remove values from array buffer? So exactly this is how you do it. Okay. Clear, Carl? And similarly, you have the minus operator also in case you want to remove individual elements from these. Okay. And then you have a bunch of other utility methods, like if you want to append to the string, append to the collection, if you want to clear the collection. So let's look at a couple of other operations which are there. So one operation we have in, yeah, Srinivas, I'm just coming to your questions only. So this is for random stuff, in the sense some comma operations are, you have something called a trim end. So trim end means, and these are all applicable to both arrays and array buffers. Okay, it's not only applicable to arrays, these are applicable to array buffers as well. Okay, so the thing is that, when you call trim end, so this removes the last two elements. Okay, so it goes there and calls the last two elements, and it's just like this. You can say arr dot trim end. So now if you print arr, you will see that 500 and 600 has been removed. Okay, so these two elements have been removed. Okay, so similarly you have something called insert. Okay, so insert, what it does is, you add the element at the second index. So in the insert, the first parameter is basically the index, and the second parameter is the value. So when you say 2, 9, so at the second index, element 9 is going to be inserted. And that was your question, Srinivasa. So you were asking me that how would I like to remove the third element. So that's how you use the remove parameter. Okay. Similarly, if you say insert and you give 2 and then followed by a list. So basically this inserts, all these numbers in the second index. Similarly, if you say remove 2, so here 2 is the index, so it removes an element from the second index. And it also has remove, another overloaded operator, where you can specify the index and also how many elements you want it to be removed. Okay, so you can say that, you can just take the list and from the second index remove 3 elements. Okay, so there are a lot of utility methods here, so I suggest that you take a look at them. Okay, Indrajit, I haven't gone to that, so just hang on. So any questions on the common operation? So I suggest you have a look at the Scala docs and go through it. Okay, now let's look at some transformation. I've already shown you the transformations here. So the thing is that we declare an array. So you remember this array we had here. So let's add a couple of more elements. So this is the array we have now. Okay, and now if I want to print each element of the array, so I can do like this. Okay, or I can do like this as well. Okay, so I can say the number, I can say arr, and then I can say println. I can do this as well, but this is more preferred. Okay, so in production, I suggest you do this. This is not how you do it. This is the recommended way of doing. And in case you want to just print out the odd numbers, you just want to check the odd numbers, then you can give the guard condition, what I taught you yesterday. Okay, so you can say if n modulo 2 not equals to 0. So you can just print the odd numbers here. Okay, so that's exactly what this example is doing. Now the thing is, if you want to collect the numbers, then you can use yield. Okay, so there's another way of doing it. But I won't teach you these things because this actually you won't be doing it like this. If you want to extract odd or even numbers from a list, this is not how you code. Okay, this is a very silly way of doing it in Scala. Ideally, in practical cases, you will be using filter functions. I'm going to teach you all these things in the next module. So ideally, you will do like this. Okay, so you will actually write code like this. Okay, instead of code like this. This is not how you do it. Okay, this is the actual Scala way of doing it. But don't worry about it. These things I'll be teaching you in the next module: filter, map, reduce, and other utility functions. Okay, good. So that's about array buffers. Now let's go to other common operations. It has utility methods like sum, max. So you can actually generally get a summary. So you have the ARR. So you can call ARR.sum. It gives you the sum of the collection. You can call max, which gives the max number and the min number. Okay, so all these things are automatically available to any numeric collection. You can use them. Okay. Now let's look at maps. So maps are like hash tables. So they are like key value pairs. So in Scala, a map is a collection of pairs, key value pairs. So I'm sure you've used hash tables or maps in your career. They are I think in any general programming these are needed. And the pair has two values not necessarily of the same type. Okay, so let's declare a map. Okay, so the thing is map m equals to map. So here you specify the key. So say for example I'm specifying the roll numbers and the name of students. So here what I did was I declared a map, and here is the key. Okay, the key is 1. So basically the key can be any data type. Okay, so here it's integer, so which may be the roll number of the student, and the value is the name, and you give an arrow here. So it's the syntax is key arrow value, and it can be of any data type. So I created a map basically where the key is integer and the value is string. Okay, and this is what my map is, and it's an immutable map. Okay, so that means you cannot change the map. Okay, you won't be able to change the map. So the thing is that, say for example, you want to delete a key, you won't be able to do that. Okay, because it says it's an immutable map. So if you want to create a mutable map, so this is how you do it. So you do an import scala.collection.mutable.map. Okay, and then you use this map here. So now it becomes a mutable map. Okay, so there are two map classes in Scala. There is a mutable and there is an immutable. Okay, and every collection comes as pairs. So there is a mutable collection and a immutable collection. Okay, so there is a map here, and if you see the map here, so there's an immutable map here in the immutable package, and similarly there is a mutable map also. So they come in pairs, mutable and immutable, and you can use the one which you want. So now what I've done is I've created a mutable map of Jenny and Benny, and this is the map I have. And if you want to access the elements of the map, so you can do like this. So you can say m, and you can give the key. It prints Benny, and if you give m2, it prints Jenny, and if you give some rubbish some key which doesn't exist, so it will give you tons of errors, saying that key not found. So there's another way of doing it. So you can call m.get 1. So it basically returns as an option. So you won't be learning options in this course. It's a pretty advanced concept. But just remember that there's a method called get which returns the value. Now there's another utility method. I'm telling you the important methods which you'll be using in the map. So it's called get or else. Okay, so what it will do is it will try to look for the key. And if the key is missing, then you can give an alternate message like key not found. Okay, so here obviously one is existing, so it says Benny. But say for example, if you give 100, so then it says key not found. Okay, and you can give any message here. So any message here. Okay, say you can say data missing. Okay, or you can actually give -100 also, anything you want. Okay, you can do anything you want here. So that's basically an important method. Okay, no, you cannot put multiple keys, Rafaela, so you can only put a single key there. Okay, and if you want to delete keys, so you can do like this. So you can give the key name, so then it's added. Okay, and if you want to add a key, so then you can again say, and then you can add the key back. So now this is how I added the key back. Okay, so no, I was just waiting for Shailaj. I was just waiting for Venkata to ask the question. He has a question. Okay, Venkat is asking me that can we use get or else without a key? No, Venkat, it really doesn't make sense, because when you're trying to get something, you can only get from a map based on some based on some key. Okay, so if you don't have the key, then how are you going to get it? Got it? So no, you cannot do that, Venkat. So when you use the get or else API, you have to use the key. So let's look at the documentation, so that you don't have any doubts. So if you give the get or else, see, if you look at the get or else, okay, so the signature clearly says that you give the key here, okay, so you have the key here, and also you give the default, okay. So if the key is in case not found, then the computation, it clearly says that in a computation that yields a default case in case no key is found. Okay, there's a couple of interesting questions. One question from Rao. He's asking me that val and var, really doesn't make any difference until we really import a mutable and immutable collection. See, the thing is that you have to understand the difference between mutable and immutable collections and val and var. So when you actually declare them as val, so that means the references can't be changed, okay? And when you declare them as mutable, or when you import them as mutable or immutable, that means the values can be changed, okay? So if you use a mutable map, that means the values inside the map can be changed. But you can still make that as a val, okay, as I'm doing here. So here you see that, I have declared a map, it's a mutable map. So that means I can change the values, but I can't change the reference because I have declared it as a val. Okay, so there's a distinction between a val, var, as well as, and on the other hand, mutable and immutable. Clearer? So I'm glad you asked this question. So mutable basically makes it, whether you can add, values, to the collection or not. And val and var basically differentiates whether you can change the reference or not at runtime. Clear, all of you? So just remember that, okay, we have one more question from Ganesh. That's also a very interesting question. Ganesh is saying that, how do I insert between keys? So suppose there's a key 1 here. Okay, so there's a key 1 and a key 2, as in this case, Benny and Jenny, 2 students. Ganesh is asking me that, how can I insert in something in between? Now, I would like to ask you, I'd just like to put the question back to you and ask you whether it's really possible. So is it possible to remove elements from, is it possible to do this kind of operation at all? What do you think? Okay, well done, Praveen. Well done, Srinivasa. So I think you got it right. See, the thing is, a couple of things you have to get in place, okay? The thing is, firstly, when you talk about a hash table, okay, so just pay attention to what I'm doing. When you talk about a hash table or a map, okay, it's basically always, in computer science, okay, it's always unordered. Okay, so it is never ordered. It's always unordered, that means it's unsorted. And why it is unsorted? Because if you look at the functioning of a hash table, they use something called a hash function, to determine, the location of the key and value, okay? So where actually your key value pair is going to be stored in the data structure, you really don't know. You don't have any clue on that. That's basically determined by the hash function. So it's quite possible that key 1 is here, key 1 is somewhere here, and key 1 is somewhere here, key 2 can be here. And after key 1, there can be key 100. Okay, so the order, definitely we don't know what is the order. It purely depends on how the hashing is done. Okay, so I won't get into the details, but just remember that in hash tables of map, they're always unordered. And so obviously, if that's the case, then it doesn't make sense to insert between keys or before keys, because the ordering there doesn't matter, it's purely random access. Clear, Ganesh? Okay, so Elijah is asking that, can we remove elements from an immutable map? Okay, what is the definition of immutable? Immutable map basically means that you cannot change the map. You cannot change the elements of the map once it has been, once it has been created. So if that's the case, then obviously you won't be able to change it. Now let me ask you a couple of more questions. Okay, now that we are, just a minute, let me see anything else is there in the map. No, I think I've told you everything about map. Now before I go to the next topic, a couple of things I want to ask you. Okay, this is related to programming, and you will be using this a lot when you're doing it, some serious Scala programming, is that when should you use mutable versus immutable collections? It's not only map, it can be anything like ArrayBuffer or list or vector, anything. So when should you do that? The thing is, just remember this, that if you're writing an API, say for example, if you're writing a function, say get customer records, okay, and this is maybe you may return Scala.collection.immutable map, and you can have the customer ID, which can be an integer, and you can have the customer itself, which is the customer object. Okay, so you can actually create something like this. Okay, I just wrote the comment so that you know what are the data types. So basically, you have something like a map like this. Okay, so here what happens is that you are sending a immutable map with customer IDs and the customer objects. Now here, the advantage of this kind of an API is that when you send it to the user won't be able to change any records. So it's more like a constant thing which he gets, and he can only query and figure out who is doing what, rather than changing stuff. Okay, so when you're designing APIs which returns values to people, so it's a good choice to make it immutable if you are sending in the form of a collection, because then that makes it more robust and flexible, and you don't have to worry about any mutation at the client side. Okay. Yes, you're right, Rafaela. So Rafaela is saying that use mutable if you're intending to change the contents, and immutable if the contents are not expected to change. Very good, Rafaela. So that's exactly what I explained now. Shailaja is saying that when the elements might change, for example, the orders of customer, then you can go for mutable, but customer name can be immutable. Absolutely right. So these are the examples, various examples. I'm glad all of you have really internalized this. And even Carl is saying that you should use immutable collections when data is fixed. So typically the thing is, you should go for any immutable types when you're returning data to the client, and the client can only take the data and maybe show it in a web page or do some processing with that. In that case, you don't have any fear that your data can get corrupted or changed by the customer. Okay, so that's the advantage of this. So that's one advantage. Okay, so that's one advantage of mutable, immutable. So basically, it's data integrity. Okay, that's one advantage. The second advantage, which surprisingly no one said, is actually synchronization. Okay, so synchronization overhead, is reduced. See, the thing is that why do we synchronize? We synchronize because it's quite possible that two threads can change the state of a data of an object. So we need to synchronize to make sure that only one thread can read the object at a time. But the thing is that if the data is read-only, so if you have a read-only data, so it really doesn't matter to synchronize. Okay, so because it's a read-only, so no matter two threads read or 300 threads read that particular data, the data cannot be changed by anyone, so you don't need to synchronize. Okay, so everybody is going to read the same stuff. It's just like the newspaper. 10 people reading the newspaper, you don't have to synchronize because nobody can change the news. Okay, so it's just printed, and whatever is printed, people read that. Clear, all of you? So just remember that the utility of that's basically the use of immutable. So first is data integrity, and second is the synchronization overhead is minimized. Okay. Clear, all of you? Any questions on this one? Yes, Ganesh, you're right. So Ganesh is saying that we are using mutable as less as possible. Exactly. I mean, we don't use mutable much unless we really have a good use case to do that. Okay, so now we come to the next data structure called tuples. So tuples actually, in more practical scenarios, you won't be using tuples a lot. because there's something called case classes in Scala, so we'll be using the case classes a lot instead of tuples. But it's good to know what tuples are, and but for all practical purpose, we won't be using tuples a lot. Okay, so tuples are more generalized forms, because we saw that when you're storing things in a list, you can only store homogeneous entities. You won't be able to store heterogeneous stuff. But in tuples, you can store more than 2 values of potentially different types. Okay, so that's the advantage. And these are pretty useless, in most of the practical cases, because we use something called case classes in Scala. But just to visualize this, just to understand. So say, for example, you are reading a table. You're reading a row from a database table. So it can have an employee name, an employee ID, and employee address. So that you can possibly read that in a tuple. Okay, so let's understand this particular thing. So say, for example, I declare a tuple val t equals. So I can write like say the employee ID is 100, employee name is John, and address is anyway, say France. So now I've created a tuple of integer, string, and string. And if you want to access the tuple, this is how you do it. So it's always, you give an underscore. First you have to give a dot, and then you have to give an underscore, and the index doesn't start from 1. It doesn't start from 0. It starts from 1. So it's a funny way of accessing. I really don't know why this is how it's done. So underscore 1 gives the first element, then underscore 2 gives the second, then underscore 3 gives the third element. Okay. And typically the use cases are, say for example, you're reading a table from a database, and as and when you read the rows, you can keep the rows in a tuple, and then you can process. So basically, you can create a row of a collection of tuples and then send it across. But usually, what I have seen, and obviously, if you can do operations like instead of 100, you can make it 200. And obviously, you cannot do 200 because you have declared this t as val. So if you make this t as var, then you'll be able to sorry, what happened? Oh, sorry. The thing is, when you create a tuple, the reference can't be changed, but the values are constant, so you cannot change tuples. That's by definition. So that means once the value has been assigned, you won't be able to change the values of the tuple. It's very similar to Python tuples, and in Python also, once you create a tuple, you won't be able to change it. So here it's also the same thing. One thing is what you can do is these are very useful, for sending data across, across processes or across, across boundaries.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!